Today, we are going to be learning about the t-test between two correlated means. Key ideas. The formula is T is equals to the summation of D over N over SD over the square root of N, where D is the difference, N is the number of observation, and SD is the standard deviation of the differences. This is applicable when comparing two correlated means. For example, comparing the results of the pre-test and post-test administered to a group of individuals. The tests must be the same. Examples. To determine whether the student's performance in college algebra will improve after enrolling for on-term, a 60-item pre-test and post-test are administered to them on the first day and last day of classes respectively. So, the first thing that you're going to do here is subtract the pre-test to the post-test. And the answer to that, we must square it, and after that, we're going to add the summation. Like so. 34 minus 45 is equals to negative 11, and you square that and it turns to positive 121. Then after all of this, you're going to have the summation. Don't mind the negative signs here. We don't mind that at all. And the summation to this. Once you're done with that, you're going to have the null hypothesis, which is there is no significant difference between the pre-test and post-test. The second one, you're going to test the null hypothesis. Note, you can't use the formula immediately. You're going to have to do some few changes for this. So, as you see here, this is the original formula that we're going to use. But we're going to use this for now, which is SD2 is equals to n times the summation of d squared minus the summation of d squared over n times n minus 1. Now you're going to substitute all of it in here and find the square root and find the answer. Now you can use the formula and substitute it. Just a few more and we're almost done. Once you're done with that, you're going to find the degree of freedom, which formula is n minus 1. Then, once you're done finding the degree of freedom, you're going to find the tabular value. And apparently, in the example, the tabular value is lesser than the CV, and which gives us to the conclusion that the hypothesis is rejected because the CV is higher than TV. There is a significant difference between pre-test and post-test. Here are a few more examples.